My name is Daniel Crowley. I work for Spider Labs. Let's just dive in. So, one quick note. I'm a web application security guy. That's what my focus is. So this talk is going to be sort of centered around applying these concepts inside sort of a web application centric world. I'm not a cryptographer, but that's okay because these attacks can be used in such a way where you don't need to know about the underlying crypto. Although obviously if you know more about it, it's going to help you. Should you want to contact me, my contact information can be found here. And these slides should be on the CD as well, so groovy. So the presentation topic is about encryption or about cryptographic oracles. We're going to be talking a little bit about encryption oracles, decryption oracles, and padding oracles, which are generally used as decryption oracles and also as encryption oracles in certain circumstances. So, like I said, little to no cryptographic knowledge is required. I'm going to be going over some basic terminology, some basic concepts. So if you don't know anything about crypto, well, I'm kind of surprised you decided to show up to this talk, but thank you. But I'm going to try to cater to you as well. So, good stuff. So let's talk about some things that are not the presentation topic. So we're not talking about the oracle. We're not being harvested for energy by robot overlords. Possibly. We're not talking about the company Oracle. Fun fact, if you Google for any crypto word followed by Oracle, you'll probably find Oracle folks asking, Oracle users asking how to encrypt their database. We're also not talking about Google, the Internet Oracle. We're not talking about cryptographic gurus like A.D. Shamir. If you don't know who Shamir is, he's the S in RSA. Also awesome, but not the topic. We're not talking about new attacks on old crypto. I will be clarifying some details on the default encryption algorithm in Cold Fusion, but that's not exactly a new attack. That's already known. It's just I've never seen it made public. I wasn't able to find any public details on why Adobe says this is a weak cipher. No, stay away. We're also not going to be talking about how padding oracle attacks work. Now, if you would like to know, the presentation from Echo Party, Padding Oracles Everywhere, is a fantastic resource, and it talks about the implementation with both implementation of padding oracles as decryption oracles and using that against a couple different things, Java server faces, ASP.NET, so groovy stuff. So I'm also going to drop little bit of Ode on the DEF CON drinking game, which is where you listen for buzzwords in presentations and then drink when you hear them. So APT iPad, APT China Cyber War, Cloud Mobile Botnet, Cloud Cyber Twilight, APT Sun Tzu, RSA HB Gary PCI SCADA in the cloud, Cyber War, LOLSEC, APT China Cyber War Weeaboo, WikiLeaks Mobile LOLSEC. So now that you're nice and primed for this talk, let's get into a primer on cryptographic terms. So some very basic stuff here. So a cipher is just a system for mathematically scrambling data that you want to be hidden from certain parties. So a cipher is a system for scrambling and unscrambling data. The key is the one part that you keep secret. The key is the part that the sort of missing variable that somebody needs to know in order to be able to unscramble the data. The initialization vector is used in a similar way, but it's not always necessarily private. The idea of the initialization vector is so almost as a second key, which doesn't necessarily need to be private, although in a lot of cases it should be. The point of the initialization vector is so that when you encrypt the same thing with the same key, you can change up the initialization vector and the ciphertext won't look the same. Now, getting onto that term, plaintext and ciphertext are the unencrypted and encrypted versions of the message, the human readable and unreadable. And encryption and decryption are turning plaintext to ciphertext and vice versa. So we can split the set of ciphers into stream and block ciphers. Now, if there are any cryptographers out there, maybe there's something else that I'm unaware of, and I apologize about that. But as for stream and block ciphers, with a block cipher, you take a chunk of the data, you take the message in chunks and encrypt each of them one by one. So the key is used directly to transform the plain text into the ciphertext. Whereas with stream ciphers, you're encrypting one character at a time, one byte at a time. And the key is used as a seed to a pseudo-random number generator. It might be worth mentioning what a pseudo-random number generator is. It generates numbers that look random but are not. For instance, you can use hashing algorithms as pseudo-random number generators. So you can use MD5 and just hash something repeatedly to generate a series of very predictable but random-looking numbers, things that are hard to predict, but if you feed the same password in and iterate through MD5 1,000 times, you're still going to end up with the same hash, the same set of numbers. And then those numbers are used to transform the plain text into ciphertext. So let's talk about some basic mistakes. One, using a keyless cipher. If you're using a keyless cipher, it is not secure unless it's totally private, unless nobody else knows how the algorithm works. And even then, it's probably not very secure. Also, reusing keys and initialization vectors. That's a bad idea, and we'll see that shortly. It makes Oracle attacks far more dangerous, and it can also seriously weaken the integrity of stream ciphers. WEP is an example of this. And leaking data from crypto operations, that sort of builds the foundation for Oracle attacks. So I've said the word Oracle several times, and now I'm going to give you a vague and generalized definition and then clarify a little bit. So an Oracle is any system that takes in user input, processes it, and gives the output. Now when we're talking about that in the sense of cryptography, we're talking about taking in plain text or ciphertext and then usually encrypting or decrypting and leaking something about that operation, whether that's the corresponding plain text to an input ciphertext, whether that's the ciphertext to an input plain text, whether it's info about the operation, maybe it's success or failure, or maybe it could be just simply a sample from a pseudo-random number generator or a random number generator, which is referred to as a random oracle. We're not really talking about that, but I thought I'd mention it. So now let's talk about how you can find oracles in web applications anyway. So first thing you're going to want to do is to try to identify input. Now when we're trying to identify oracles, it's easier for us to identify encrypted data. It's a lot easier to find than data that's going to be encrypted, because how can we tell? So when we're looking for decryption oracles, we're going to look for ciphertext being passed in as some sort of input. So you're going to want to look for all points of user input, get, post, URL, anything in the cookie field or in HTTP headers, which is a little bit rare but can happen. And then identify those which might be encrypted. Usually when you have encrypted data, it spans a pretty wide character set, so it's not really possible to put that through the majority of systems, and something might be interpreted as a meta-character. So usually you have some sort of encoding scheme, whether that's URL encoding or base64 encoding or just putting it to ASCII hex. So if you decode that data and it looks random, and there are some tools out there for doing entropy analysis to see, how random is this. So another thing that you can do is modify the values. Sometimes this will generate, this will give you decryption related errors. The other thing is, if you modify a value in the middle of some piece of ciphertext, it might, you might see some text, resulting text on the response that is fucked up beyond a certain point. So here's a little bit more on that. So when you're looking for the decrypted output, it might be reflected immediately to you in the HTTP response. Again, still talking about web apps. Or it might be in an error. And this is something that's a little trickier. There's a lot of systems where the data might be processed, but it's never going to be given to the user. which is probably the proper way to do things. But some errors will leak information. I'm sure many of you are aware of that fact, but this is also important in the context of oracles. So it might be given a later response. So your data might be processed and then put somewhere where it's not going to be given back to you immediately. You need to find it somewhere else. It might be inferred from modified output. So maybe based on what the plain text is, you are getting different things. It might be stored and not shown. So encrypted data is often written to files or into databases. One example of where you might find an encryption oracle is through the use of an SQL injection flaw. So if you find an SQL injection flaw, you can find some piece of data that's encrypted in the database, and then as long as you can add data or change data, let's say that passwords are being encrypted in the database, then you can change your password repeatedly and use the SQL injection flaw to look at what your password has become every time you change it. So this allows you to use it as a sort of encryption oracle. And I've actually done this before, and we'll talk about a little bit more about the instance where I've seen that. So here's an example of where you might find a decryption oracle. So when novices are writing web applications, they frequently write one particular kind of file inclusion flaw in a script that's supposed to just make their lives easier. So essentially what they're doing is including a header, some page that gets passed in by user input, and then a footer, so that they don't have to put the header and the footer and everything, and they can change the header and footer for all the pages arbitrarily at any time they wish. So let's say that this developer found out, oh crap, I've got a file inclusion flaw. I know, I'll sprinkle magic encryption dust on it. So you encrypt the input, and that way you expect nobody is going to be able to, you know, do anything with this. Now, maybe. So let's assume that the errors are verbose. So if you take some ciphertext from somewhere else, let's say that they're using the same key and initialization vector and same cipher in some other place. You can take that, ciphertext and plug it in here, and if it's not going to point to some valid file, the application is going to respond by saying, hey, I tried to open this path here and it didn't work. And that path will of course include the decrypted output from this operation. So that's an example of where you might find a decryption oracle. I put a picture of a kitten in here so that it wouldn't be just such a wall of text. It really has no relation whatsoever to the content. Thank you. I like the cat too. So again, we're looking for encrypted data when we're talking about encryption oracles, but in this particular case we're looking